Okay, here we go. Reflexive property. Same on both sides. Anything equals itself is really what we need to say with this. Anything equals itself. So A always equals A. 5 always equals 5. Anything always equals itself is reflexive property. Everybody good with that? Now we get to the one I was trying to jump ahead to. The symmetric property. What does it mean to be symmetric? They look the same on both sides, right? Symmetric property says that if A equals B, then B equals A. Let's put some numbers in here. If 3 plus 2 equals 5, then use the symmetric property. What does it look like? Or y'all are doing a commutative kind of thing. You're changing the order of the addition instead of the equal sign. The symmetric property deals with the equality sign. Number 3, I think I'll just lay these out here and then we'll analyze some expressions and talk about the properties that's being used each time. Can I go forward? You need a second? All right, number 3. Transitive property. These are really big names for very easy concepts. Transitive property says, let's say I have, if I tell you that A equals B and B equals C, tell me what you can conclude from that. A has, they're all the same thing, right? So then A has to be the same as C also, right? It makes sense if you think about it. It's just real confusing the way it looks. So maybe we'll put a note. These are all the same. Yeah. You're just looking like if I told you that X equals 2, and then I also told you that 2 equals Y, what can you tell me about X and Y? They have to equal each other, right? Because they equal the same thing. That's the transitive property. That's all it says. Again, it's a big fancy word for a really easy concept. I'll give y'all that. It's okay. All right, number 4. Substitution property. It does exactly what it sounds like it would do. Sounds like it would do what? Replace or sub something in. And you've already been doing that, really. If I told you that X equals 3, and you told me that 5X equals 5 times 3, this is the substitution property because you substituted in the value for X. I'm going to say replacing equivalent values. So you substituted in for something that's there already. If I go too fast through these, let me know. All right, number 5. We're going to get into some identities. Do you know what an identity is?
Yes.
What?
Well, I know properties are.
All right, so what an identity is, it can be done with multiplication or with addition, but what it means is it's something that you can add to anything and the value stays the same. So I want you to think about that just a minute. What is something that you can always add to any number in the whole wide world, and the answer stays that number? 0. 0 is the additive identity. So A plus 0 is A. Okay? 0 is your additive identity there. If I jump and change this from additive identity to multiplicative, that's the big word. Multiplicative just means multiply. Exactly. Good job, y'all. It would be 1. These, you see what I'm talking about? These are just big fancy words that describe things you already know. So y'all are right. The multiplicative identity would be 1, because anything times 1 is itself. I'll give you a second to catch up. Let's talk about inverses. What number am I on? 7? Additive. So again, I'm talking about adding, right? Additive inverse. Here's what the inverse means. The inverse means here, when you add it to anything, you get the identity. Now, what did we say the additive identity was? 0, right? Okay, so if I have some number, let's say x, I need to add something to it here so that I get the identity whenever I add it. And the identity we said was 0. So what would I have to add there? Negative x. Right? So the additive inverse is really just the opposite sign of what you started with. Am I going too fast through these guys? Y'all okay? Tell me this. What is the additive inverse of 5? Good job. What is the additive inverse of negative 2? Positive 2. Y'all okay with these? This is not the kind of math that I always like, just naming properties like this, but we'll get through it. Let's do the multiplication inverse. Actually, not multiplication, but multiplicative. That's a good word. You should go home and tell your parents. I learned about the multiplicative properties today in math. Multiplicative inverse. So remember, an inverse is whenever, this time not whenever I add something to the number, but whenever I multiply by something to get, oops, come on, the identity. Now, what was the multiplicative identity? 1. Okay. This one you have to kind of think about a little bit. I'm going to give it to you as a number first. Let's start easy. Let's say 2. What do I have to multiply 2 by to get 1? 2 times what is 1? 2 times negative 1 will be negative 2. I told you this is hard. This one you got to think about. 2 times 1 is 2. You're exactly right. Give it to me as a fraction, though, because it'll be easier to see. 1/2. Okay, let's see. How about, what would you need to multiply 3 by to get 1? Okay, I hear 1 and 1/2. 1/3. I agree with 1/3. Why? Can you do that? Let's look. 3 times 1/3. Put 3 over 1, right? When we multiply fractions, we do top times top and bottom times bottom. So 3 divided by 3 is 1. Oh. How about 5? What do you think I could multiply 5 by to get 1? 1/5. Good job. Let me make it a little bit harder. What do you think I could multiply 2/3 by to get 1? Did you just throw 7 out there? Yeah, it's not 7. Nice try, but it's not 7. No. It is. It is. Explain why it's 3 over 2. That was a good job. What'd you do? What made you think it might be 3 over 2? That's exactly what you do every time. Good job. She's flipped it. That's exactly what you do. That's all I'm doing here, right, fellas? Is I'm flipping. David? All I'm doing is flipping, right? When you flip 2/3 times 3 over 2, if I do top times top and bottom times bottom, you get 6 over 6. So the multiplicative inverse.
Shouldn't that just be 6?
Over 6.
6 over 6 is 6, right? No, it's 6 over 1.
2/3, look, 2/3 times 3 over 2. What is 6 divided by 6?
I'm thinking of 6 over 1.
Okay. How about A over B? What is the multiplicative inverse? B over A. So you see the pattern here? That's a good job. See, y'all did that all on your own. So we flip. I'm going to put it here. We flip whatever we have to get the multiplicative inverse. Everybody okay on that? That must be something new for us. No? Maybe. Maybe we forgot. Got to brush off the cobwebs a little bit. All right. Number 9. Multiplicative. I like that word. Multiplicative property. This is an easy one. Of 0. What happens when you multiply by 0?
You get 0.
Every time?
Yes.
Yes. It doesn't matter what the number is. Every time you multiply by 0, you get 0. Anything times 0 is 0 every single time. Anything times 0 is 0. All right, here's what we're going to do. We're going to evaluate, before we do the last 2 properties in this section, we're going to evaluate a couple things, and I want you to tell me the property you see being used each time. And there's different, you can do these different ways, but we need to watch our order of operations as we go through here. All right, so we're going to come back and pick up at 10 in just a minute, but we're going to sidebar here just so I can do a couple examples on what we've done so far. Evaluate, let's say, I'm going to pull this one out of the book because it's a good one. You got to do the parentheses first. So the parentheses would be 4 minus 3. What does 4 minus 3 equal? 1. So if I put 1 in place of this, what property have I used? What's it called? If I put 1 in place of this, I'm replacing something with something else. Yes, substitution. This is substitution. That's the hardest one for me to see sometimes because really it looks like you're just simplifying, right? So that's substitution when we sub in a value for that. So we know that 4 minus 3 is 1, so we substitute 1 in for that. All right, what do you see that we should do next? So multiplication left to right would come first. Yeah. So here, so 7 times 1, what property is that? Multiplicative identity. I'm going to just put an abbreviation here. Multiplicative identity. What now? You should multiply. That's exactly right. What is 5 times 1/5? 1. What property? Multiplicative inverse. Good job. Now what? 7 minus 1. And anytime you're just doing a basic add or subtract like that, it is substitution. Now what's 6 plus 1? What's the property? Anytime you're just adding or subtracting or multiplying and dividing to get a value like that is substitution. Because you can come over here and say, okay, well 6 plus 1 is 7. I'm going to substitute this with 7. And put 7 in its place. Let's do one more.
Let's do it.
Love the enthusiasm. Can y'all see that color okay? Okay. Oh, that's purple. What's first? Parentheses. So what should I do in the parentheses here? All right, so I've got 2 times 3 plus 8 minus 8. What's the property? Substitution. If in doubt, it's probably substitution. Okay? What now? Subtract. So 8 minus 8 is 0. What's the property? When you get the identity, additive, close, inverse. The inverse gives you the identity. Okay, what now? 2 times 3 is, what's the property? Actually, this is just substitution, yeah. You multiplied, but it wasn't an inverse or an identity. 6 plus 0, what do you get? What's the property? Ooh, close. Additive identity. 0 is the identity for addition. Believe it or not, this really will help you get better with your order of operations and stuff as you go through. What you telling her all the way across the room? That it was the additive inverse, that's what you was telling her?
Yeah,
You was explaining that to her. That was so kind of you. So kind. All right, what number did I say we were going to pick back up on? 10. Number 10. This is one of my favorites. Commutative property. What does the commutative property say? You can switch them around. That's exactly right. The way I remember it is, yeah.
She got mad.
Hold on. Explain this to me one time, and I'll never forget whenever I was taking algebra, and it's how I've always remembered. Because I always got commutative and associative mixed up. So they said, think about when you commute somewhere, right? Commute meaning drive somewhere. You can drive to school one way, go another way back home, but it's still the same thing, right?
Yes.
So commutative means you can do it in any order. Okay? I don't know why, it just makes sense to me. All right, so tell me what operations we use that are commutative. Multiplication and addition. Because for multiplication, 2 times 3 is always the same thing. I should put it here. As 3 times 2, right? The order does not matter. And then with addition, bless you, 2 plus 3 is always the same thing as 3 plus 2. Does that make sense? Okay. I take it by y'all, what you're telling me, that y'all know that. You're good with that? Okay. Associative is the one I struggle with the most. What number are we on? 11? My goodness, we've done a lot today. We hadn't even got to my favorite yet. Who knows what associative property means? So it does have something to do with numbers. They all do. These are properties of numbers. Good job. Associative property means you can group things together in whatever order you want to group them in, okay? I remember this being explained to me as like the friends that you associate with school, and maybe you change your group of friends and you associate with these. I don't know. It's parentheses. The parentheses can move around on these, okay? So associative deals with parentheses. So 2 plus 3 plus 7 is the same thing as 2 plus. As long as that's the only operation you're doing in there, you can move those parentheses around. And it really is, it goes hand in hand with commutative, because I could add 2 and 3 together first and then add 7, or I could add 3 and 7 together and then add 2. Okay, same thing, that's addition. It also works with multiplication. 2 times 3 times 7 is the same thing as 2 times 3. 7. Let's do everybody's favorite. Everybody good now? You feel a little better? You stretched a little bit? Some of us did. Some of us are still sitting right where we were. All right. So continued on. This is where 1-4 picks up. Okay. So this is property number. Did I say 11 or 12? Oh my goodness. We've done a lot today. All right. Distributive property. Everybody's favorite. Everybody always wants to distribute. Let's say that I have, let's start with some numbers first. Let's say 2 times 5 plus 3. What does the distributive property say? Because normally we'd add that 5 plus 3 together first, but I can use distributive property here also. Yeah. Exactly. What's on the outside multiplies, yep, to everything on the inside. So I get 2 times 5 plus 2 times 3. What's 2 times 5? 10. Y'all are on it. What's 2 times 3? 10 plus 6?
16.
All right. I don't feel good about doing this whole section today. I feel like we've done enough today. I'm going to stop. I'd rather take a little bit longer and be